Alright, so let's take a look at some of these problems from our modeling. Here we're just going to write the equation, but this time it's going to be helpful when we have both phase shifts going on and changes in the period. Phase shifts are shift to the left or to the right. If we think of our form in this form, to write these sines and cosines. So here they want us to write sine curves. Let's identify the period, one cycle. So let's find a nice starting point. Well, let's identify the center line. So the min is -2, the max is 0. Um, add those together, divide by 2, and that's my center line. It's easy to see that there's one cycle that starts here on that center line and goes like that for the sine curve. So for the period, this 4 pi over 3 minus this x value of -2 pi over 3 gives us 6 pi over 3, which is 2 pi. The amplitude, the distance from the center line to a max or from the center line to a min is 1. Those are distances and they're always positive. The center line is here at y equals -1. And what they mean by a starting point, we want to, for the sine curve, find a point on this center line where it's going up. So if we wanted to, we could choose this -2/3, and it's a shift to the left. Now you do have to remember that it's bizarre and that we'll write it as addition. Or if you want to, we could choose this and have a shift. Well, but then we'd have a negative reflection there. So that's going to be more challenging to write. Let's go back and choose that first one right there. Let's choose this as a starting point, an x coordinate of -2 pi over 3, comma, -1. So for the sine curve, we're picking a starting point that's on the center line. Alright, so let's now write our equation in this new form here. We've got the amplitude was 1. Now we don't have to write 1, but I'm going to, 1 is implied there. 2 pi divided by the period. Well, the period is 2 pi. The phase shift, since this is moved to the left, I'm actually going to have addition there, and that's 2 pi over 3. And my center line, y equals -1, so this will be -1. So I've got the sine of x plus 2 pi over 3 minus 1. Alright, so I'm going to move on and do the next one in this same video. Alright, so from -3 to +3 is the range. That puts our center line as the x-axis. That's pretty easy to see. The cycle here, the nice starting point is going to be the origin, and it goes to there. Alright, so the length of that cycle from its start to its finish has a length of 4, so that's the period. The amplitude is 3 units above or 3 units below the center line. The center line is the x-axis, which has an equation y equals 0. We may as well use the origin as the starting point for the sine curve. That's the most convenient. So the amplitude was 4. No, excuse me, the amplitude was 3. The period is 4. So see, if we want to find the coefficient in front of x, we take 2 pi divided by the period. We don't have a phase shift. We're not shifting the graph to the left or to the right, nor are we lifting it up or down. So what do we have? We've got this equation to be 3 times the sine of pi over 2 times x. Alright, I'm going to go ahead and do the next one on here as well. Let's paste our form here. Alright, now a nice cycle to pick. We could pick anything that goes up and down, but this is going to be probably the most convenient one, because for sine, if we start at the center line and go up, so yeah, this is my center line. My period from 3 to negative 1, that length is of length 4. The distance from the center line up to a max or down to a min is 2 units. That's my amplitude. My center line is the x-axis, which is y equals 0. And I'm going to pick this starting point here at negative 1, 0. So my equation, my amplitude, 2 pi divided by my period. And this time, since my phase shift is to the left, I'm going to add, and I add 1 unit. And there is no vertical shift. The center line is 0, so we have our equation. And, we should reduce things if possible. 2 times the sine. 2 pi divided by 4 is, that kind of scared me. Oops. Alright. So I need this in factored form. And then I'm not going to put the plus 0. So, and sometimes you'll see brackets here. Alright. Let's take a look at this one. Alright. Let's find from a maximum of 1 and a minimum of negative 5. Negative 5 plus minus 1, that's a 6. Or negative 5 plus 1 is negative 4, and half of negative 4 is negative 2. And so we're 3 units for our amplitude. 3 units above to the max, 3 units below to the min. A nice cycle to pick for our basic cycle is right here. Alright, so because we're writing a sine, if we had been writing a cosine, we would have, picked a point up here at the maximum. If we pick this point from here to here, this period is 2. This amplitude is 3. This center line is at y equals negative 2. I'm going to pick as a starting point 0, negative 2. Let's write our equation. Our amplitude 3, the sine of 2 pi divided by 2. Since I've not shifted to the left or to the right, I have a vertical shift of down 2 units. Alright, so that gives me an equation 3 times the sine of pi x minus 2. Alright, I'll do these application problems on a separate video. So talk to you later.